Okay, so once again, let's try and define our function. So I'm going to scroll up, find a define statement. There we go. Define f1 of x equals negative 15 cos 4 pi x on 5 plus 25. So another advantage of using an existing function is that the brackets are in the right place and all those sorts of things. Now, have we got any idea of what our domain might be? Down low, they talk about 0 to 5. So what if we just do that for now? What if I just work with 0 to 5 for now? Okay, so there's my function. What is the amplitude? What is the period? Okay, so really the calculator doesn't necessarily tell us, but I tell you what, if we do type in 2 times pi, which is 2 pi on, well, what's my n value? My n value is 4 pi on 5. So notice I put a bracket, 4 pi on 5, bracket. Oops. Would have worked better if I'd have done down here, sorry, pi symbol is 10 on 4, which is 5 on 2. So there's my period, okay? What is the period of the function? Okay, on the set of sketch the graph of the function between t 0 and 5, indicate the coordinates of endpoints and turning points. So again, let's go to our graphs, tab function, scroll up, just reread my function, make sure, negative 15 4 cos plus 25, okay. Enter. Obviously I can't see my graph straight away, so let's change my window settings. We've got to remember that the cos function itself is sort of 1 to negative 1. So I reckon negative 15 plus 25 is about 10. Negative 15 minus 25 is negative 40. So that's my y values. My x values, well, it says t is greater than 0. So I might just put negative 1 to say 6. And we just spoke about, say, negative 50 to, I don't know, 30. So we can nearly see plus 25. So there's my graph, right? So remember we've got to do maximums, minimums, endpoints. So let's just do a little bit of an analyzed graph. 1.25, that's okay. All right, so there's a nice exact value. So it looks like we're going to get exact values here. Another maximum, 3.75, which is 2.5 later, which is the period, so that's good. So just go through, analyze your graph again, minimum values. Yeah. Analyze graph, we'll get a minimum at the function. So at the point 510, there's 1 point, endpoint. Analyze graph, the minimum. And that's obviously 0, 10. All right, so there's my key points. I can put them in. Don't forget, I could quite easily, if I wanted to find my maximum or minimum, where's all the typing that I had done previously? Oh dear, where's it gone? Is it up there? Oh, there it is. So we could solve our function. So we saw the maximum. Quick check again of my graph. The maximum was at 40. So if I solve my function equal to 40, well, there's the values. My minimum value was at 15, I think. Control enter. Maybe it wasn't at 15. What were the minimum values at? Oh, 10. So let's go back up. 10. Okay, and there's my minimum value. So we can use our solve feature as well. So we're going to put that into the graph. My average value is the halfway mark, so it's between 10 and 40, so half of that is 25. So there's my halfway mark. So what's part E? Production, one batch of the product. For how long is the volume of the mixture in the jump increasing? So same sort of thing, it's increasing. So it's increasing between 0 and 1.25, between 2.5 and 3.75, so it's 1.25 and 1.25, isn't it? So it's increasing for those lengths. Although for one batch, what's one batch? Gradually siphon the process over and over. So one batch, okay, so one batch is just one cycle, isn't it? So one batch is from 0 to 2.5, so it's increasing for half of that time, 1.25 hours. So for how many hours would the machine need to run if 3 batches of the product were to be produced? So 1.5 there, 1.5 there, so it's going to have to go for another 1.5 hours. So it was 5 hours. We could always check it. I think if we increased our domain from 5 to another 1.5, so 6.5, slide my graph across, yeah, little quick analyze graph, so 6.25, so it's for 6.25 hours, isn't it, for part F? So it's just having the graph in front of you and being able to read the graph. On a particular day, the machine was turned on at 7 a.m. and turned off at 5. On this day, how many batches were produced? So first of all, how many hours is 7 a.m.? Well, it was just turned on at 7 a.m., so it doesn't say anything. So how many hours did it run for? So it's run for 5 hours, 10 hours, hasn't it? So again, if you're not sure, the period is 5 on 2, but if I change my graph to, oops, Apple Z, where's my function? There it is. What did we say? It was going to go between 7 a.m. and 5 p.m., which is 5 hours, 10 hours. Enter. So let's just change my window to be between the X value from negative, and let's just change that up to, say, 11. So how many batches have been produced? We've got 1, 2, 3, 4 complete batches, haven't we? Let's just read, what's the definition of a batch? Gradually added to the drum whilst being mixed, and then the completed product is gradually siphoned off. Yeah, so to complete one batch, it's got to be filled up and then emptied, then filled up, then emptied. So we've got 5 complete batches there. Okay, on this day, what was the volume of product present in the drum at 11:45? So at 11:45, how many hours had passed? So we've got F1 of, well, how many hours is 11:45? So 11:45 is 4 3/4, isn't it? So 4.75. So we've got 12.86 litres of product in there. All right, on this day, what time did the volume of product in the drum reach 32.5 litres? So, arrow up, solve, except I want 32.5 litres of product. Now, don't forget that this might only be for 0 to 5. Okay, in fact, I'd rather it be an exact answer. So instead of 32.5, I'm going to put 65 on 2. And that way I get proper fractional hours. So my domain's increased. The first time, so the first time is after 5/6 of an hour. So 5/6 of an hour is 50 minutes. So it's 750. The fourth time, 1, 2, 3, 4, is 25 on 6. So that's 4 hours and 1/6. So 4 hours and 10 minutes, which is 11:10. All right, so use our calculator to solve the function values that we need. During the making of one batch of the product, for how long is the volume of the product in the drum 32.5 litres or greater? So maybe if we want, let's just put a second function f2 of x equal to 32.5. All right, so now if I go to my graph, oh, what's happened there? 32, oh, I didn't define it, did I? So there's that. So now we can see clearly the points of intersection. So if I find the point of intersection, we'll just get one of, maybe a couple of them. 0.833, notice it's a decimal. And if I get the next one, no, sorry, not the minimum. Analyze the graph intersection point, and there. So those values of 0.8333 and 1.66, they correspond to 5/6, 5 divided by 6, yeah, and 5 divided by 3. All right, so what's the difference? That, oops, I should have put a minus sign in. Subtract that. So it's 0.8333 different. So if we look at the curve, it's the difference from there to there is 0.833. How many of them have we got, or how many days we have to do it? Oh, during the making of one batch. So it's just 0.833 of an hour. So what's that? Times 60, 50 minutes. So during the making of the product is only there for 50 minutes. So it's about interpreting the question. The easiest way is have a picture of the question, yeah, and then analyze the graph. Okay.